Okay, so I hope my screen is visible to you and I'm audible to you. Uh, in case you have any doubt, you can ask me. Okay, so hello everyone, and I'm Kamna Mishra from IIT Mandi, and we are here for the eighth week of problem solving session of probability and statistics. Uh, this is by instructor uh, Somesh Kumar sir from IIT Kharagpur. And for today's class, we will just go through the basic, median, mode, and then after that, we will go through the chi-square distributions. So, so basically, we will go through three distributions: chi-square distribution, t distribution, and then last one, uh, distribution. So these are the distribution which helps us basically when uh, x follows normal distribution and then we want to see what is x square follow or x by y, or f distribution is basically for the variance part. And before all these we will go through uh, the basic, mean, median, and so you may have I think have previous knowledge about these things: mean, median, and mode. So mean is basically the average value we will find so that we can understand that where is our uh, most of the part of the data belongs. And then we use the mode, that is there any specific point where it is repeating again and again and again. So in the real life, these things have their value. Like when we see the temperature, we see the mean temperature generally, so that we can just know that we cannot understand this, that uh, like we do not find the temperature at every point or every minute or every hour generally. So we say that total overall temperature was high for today, so that we say that mean temperature. And then we use interval estimation so that we can say that it is around in between this. And then median is where a data covers half of its part, so it's median. And then mode is that if there is something which is occurring again and again and again, so then we work on that particularly, that why is that. So these are some things, but here we will just go through some simple maths just to understand that how do we solve all these things. Okay, so we will start from the first question. Now, first question is that what is the median of the following data set? So if you have data set like this, let's say this is the data set. So to find the median, what we need to do firstly, does anybody know? That if we want to find the median of any data, what should we do? Okay, so find to find the mean or to find the mode, it is not required, but to find the median, it is required to sort the data firstly. So if the data is not sorted, then we cannot find the median. So you can sort the data in any way. first one is that in increasing sequence, and second one is that in decreasing sequence. So increasing it, you most probably know the meaning of all both these words. So firstly we will just sort the data in the increasing or decreasing sequence, and then we will try to find the median. So first one will be 2. Sorting the data in increasing. You can sort in other way. So first one will be 2, 6, and then I think 13 and no, 12, 13, 15. So 2, 6, 12, 13, 15, and then 17, 17, and 21, 27, 30. 21, 27, and then 30. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. Okay. So for the median and for the discrete, to find the median for the discrete data, as you can see here, this is the discrete data. What is the formula? It is if n is odd, then the middle term is the median, and if n is even, if n is even, then it is n plus n. Sorry, it just the middle two terms divided by 2. So n plus n plus 1. These two terms divided by 2. So here n is odd. So we will just take the middle term. So this one is first, second, third, fourth, fifth. So this is the middle term. So 15 will be the answer. Very basic, very simple. Okay. Now the next one is that suppose the observations are arranged in the ascending order, and we need to find the x if median of the set is 24. So firstly you can see this is 1, 2, 3, 4, 5, 6. Okay. So 6 terms are there. Just a minute. So we have 6 term, and median given here is 2. So n is equal to 6. So we will take 2 medium terms, and this is given that observations are arranged in ascending order. So observations are already arranged. So this is, and this is in increasing order. So x must be greater than 15 and x plus 10 must be greater than 21. So now this is 16, so median will be the average of middle two terms. Average of middle two terms. Because when it is even, we will not have one term as a median. So will be what? 21 plus x plus 10 divided by 2. So this is given as 24. It will be 48 is equal to 21 plus x plus 10. So x we will have will be 48 minus 10 will be 38, and 38 minus 21 will be uh, 7, and then 38 plus 21 will be 7, and then 1. So it will be 17. So x is 17, and we can see that it is greater than 15, and then 27 will be greater than 21 too. So you can just check. So 17 is the answer. Okay. Well, I hope you don't have any issue, but if you have, you can just ask me. Okay. So next question is that we need to find this sample mean and sample standard deviation. So if this is sample, and let's just say we are denoting this sample by xi, we are just denoting the sample xi, and we have this sample 15.92, and then 16.27, 15.41, 15.48, 17.28, 14.98, and 15.8. So we have 1, 2, 3, 4, 5, 6, 7. So we have seven number of observation. This is xi. Then what is sample mean? What is the formula for sample mean? If we have seven values, then what is the average of it? I think you know it. So okay. So average is what? Average is sum of values divided by a total number. Okay. So we will just do its summation. So its summation will be what? It will be 114.19. Okay. So average or mean value will be equal to 114.19 divided by uh, 7. So that one will be 16.13. Now what we need to find is that we need to find the standard deviation. Now to find the standard deviation, you can do it in two ways. Firstly, what you can do is that you can find xi minus x bar whole square, and then you can write the variance. A standard deviation will nothing but just under root, so that you can do. So that one will be 1 upon n minus 1 summation xi minus x bar whole square. So this is the variance formula. Now also the variance you can find by 1 upon n minus 1, and then sigma, uh, sorry, just write expectation of x square minus expectation of x bar, or x bar, just x bar whole square. So x bar is mean. So this is also the variance. So you can find this by two ways, right? So first one is that you can find xi minus x bar whole square. Second one is that you can find xi square, and then by after finding xi square, you can just minus xi. Okay. Okay. So there are just two ways you can find in any way, and then we can check whether it is equal or not. Whether, well, there is no need to check. Uh, it just depends on how you want to calculate the values. So now, if you want to calculate in this way, like uh, rather than this way, we can calculate by this way. So this is 16.13. So what we need to do is that we can just simply subtract it and then take the minus. So it will be 16.13 minus 15.92, which will be 0.21. Okay. And then 0.21 square is 0.041. Or it's just better to do directly square. So I'm leaving this way. You can try on this way and then you can check whether the answer is same or not. And then right now I will do it this way. So it will be 15.92 square, 253.44. Okay. Now other thing is that uh, yes. So do you know how to use calculator for all these things? Okay. If not, you can just go to YouTube or you can just check on the calculator with me. So there is option third for the stats, and then you can just click on any, I think first one. Yeah, and then you can put the values for x, all these x, and then let's just say I'm putting all these values 15.92 and then 16.27, 15.41, 18.48, 17.28, 14.98, and 15.85. And then you need to just save it, and then you can click on the both, and then third one is sigma x, fourth one is sx. SXX. So then you need to click on the SX, which will be sample variance, and it will come in as 1.19. Okay. So do you guys know about it or not? Okay, if not, I will just write it down for you so that you can just go through it. Okay. So in the calculator, you can do simple this. Firstly, go to mode or setup whatsoever is given, and just click on the third, which is stat, and then click on the first, which is 1 minus where, something like that, and then you need to uh, click on first, and then these are the things you need to click on. Okay. And then third point is just that, put the data, and once you put the data, just uh, click on AC. Okay, this will save your data. So whatsoever you give, I'm just giving 2. Okay, and then after AC, fourth point is that use shift 1, shift plus 1. Okay, and then fifth point is that go to 4, click on 4, and then you can find there whatsoever you want to find. X bar, Sx will give you sample variance, sigma x will give you the total variance, and all in all, and then you can find it. So you don't need to do these all calculation on your own. But otherwise, for right now, you just go through all this so that you will understand that how this formula works, so that you will just if you are actually not comfortable with these things, like if you are not able to remember these things, then you can just do some, so you can just do some questions based on this, otherwise you can leave this, it's not too important. Okay. So next one is, again we have some run is scored in a cricket match, and then for the 11 players, and then we want to find its mean, median, and mode. Now other thing is that about the mode, like mean and median will be a one value, okay, but modes can be more than one, because let's say 15 is repeated three times and 17 is also repeated three times, so mode can be more than one. Okay. So mode can be more than one. And then what we say is that this is bimodal data or trimodal data. Even sometimes it happens that, let's say we have the data like this, we have the continuous function and it is like this. Now, if if we will consider just this peak, it's not good really. So we should also consider this peak also. So what we say is that this is bimodal data with these the modes. That means these two values are occurring the most in our data. So it may also happen is that you have 10,000 number of data, and one value is occurring 500 time and another value is occurring, let's say, in 10,000, let's say data, this is size of data, and we have first value which is occurring by 500 times and another one is occurring 490 times, and all the other values are like 10, 15. So these are basically two values which are occurring a lot many times, so you will consider this also as mode. Here we are not considering because in 10 2 matters, 3 matters, uh, but here to actually see the data we will use this also as mode, and then we will say this is bimodal data. So it depends. Okay, so I was on this question and I was just telling you that mode in the time of median and mode, it is for median and mean it is always one value, but the mode can be more than one. Well, for the data we take, it may happen is that 15 occurred three times or 17 or 19, all these values are occurring three times, so all three are modes. Mode is basically the data which is occurring again and again. But when we work on the data which is so big, which is so large, then we see, I was just telling that if we have data like this, let's say n is equal to 10,000. Let's say we have the data for temperature or maybe for rainfall for like mm, maybe 100 years, and for every day we have the daily data. So then what we see is that if a value is occurring 500 times, if and if another value is occurring 490 times, then also we take 490 as the mode value, and we say that this data is bimodal data. Okay, so if you deal with the large number, then we can take more than one modes, even if it is not occurring a lot many times. Sorry, if it is occurring a lot many times, but it is not equal to the highest number of occurrence. So now for this data, simply what we will do is that now since we also need to find here the mode value, sorry, median value. So firstly we will do the sorting. So we can sort the data in a way like one, and then two, sorry, five, and then I think 15, again 15. Okay, so 1, 5, 15, then 15, 15, 15, and then 2. Next one is 17, and then I think 29, 62, 71, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so 11 players data. So this is 11 values. Now to find the mean, what we can do is that simply you can just sum it and then divide, or you can again use the calculator if you want. So then you can find the mean from this, and then median will be like it is 11, since 11 is odd, so the mid value will be the median. So 1, 2, 3, 4, 5, 6. So 6 1 will be the median as 11, so 6 1. So 15 will be the median. So you can see 15 and then mode is that 15 is occurring three times and all the other values are occurring just one time. So mode will be 15 too. So 15 and 15 you can just do this, and then you don't need to calculate the mean value here, because this is the only option with 15 and 15. Okay, and then we will move to the next question. So next question given here is that here are the measurements of photoresist thickness of 8 wafers baked at two different temperatures, and then we want to find the standard deviation on the difference of the thickness. So firstly, we will find the difference, and then to find the standard deviation, we can simply use its formula. Okay, let's say that you have given the data like this, like this. So if you find the difference, you will have the data like this, right? So 111 value xi, and then you can find the standard deviation for that data. So just we can simply subtract it. So it will be 5.2, then 6.85 minus 7.58. So it will be minus 0.73, and then 5. So it will be 3, and then 14, 6, 8, and then 8 minus 5, 3. So 3.83. Next one will be 21 minus 516. Okay, let me just write it clearly. So the difference will be 5.2 and then minus 0.73 and 3.83, 1.16 minus 1.55, 2.904, 5.57, and then 7.0. Okay, so these are the differences, and then now you can just put the values. So to find the standard deviation, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 values. So its formula will be 1 upon 8 minus 1. This is variance, and then summation xi minus x bar whole square, and then you can solve it, and the answer I tell you is B. This one is the answer. So I just don't want to waste the time. That's why I'm not doing any calculation here. But you can do the calculation if you think that you need the practice of calculation, because I'm already very bad in this. So most probably I'll solve the wrong. Okay. Now sixth question. So sixth question given here is that we have the data, and then we have CVA, CVB as coefficient of variation of data. So do you know what is coefficient of variation of the data? Okay. So coefficient of variation, we generally call it as COV. You can write it as CV also. So this CV is sigma upon or S whatsoever you have. Here is the sample, then we will write it as S. Okay. So S or sigma whatsoever is this. Sorry, S upon X bar. So this is basically that if standard deviation is high and mean is very low, then that means is that there is high variation in the data. Okay, so coefficient of variation will be high, and if the variation in the data, that means if variation is basically what, the mean value and then how much it is variating from the mean. So data is how much variating from the mean. So if you have any data, let's say this, and if you have any like this, so what do you think, which one has high coefficient of variation? Let's say out of 1 and 2. You can write the answer. Yeah. No. Second one has less variation. Okay. Let's just see this. Okay. So this one is the mean. Ah, yeah. Okay. Yeah, that's different. So variation is this. So this is low variation. This is high variation. Okay. So the more flattened your data will be, the more will be the coefficient of variation. Simple. Okay. So now the data is discrete here, so we will just solve it. We will find the S and mean value. So again, I'm not doing any calculation. I'm just writing it here. So for the first one, A and B, let's just make the table. Okay. And for this X bar and S, so X bar, you can calculate it here. So these are the value, and X bar will be So this is 1, 2, 3, 4, 5. Okay. So it will be 1 upon 5 summation xi. So for A, it is AI, B, BI. And then S, S. S is the standard deviation. So for standard deviation, it will be 1 upon this 5 minus 1, 4. And then xi minus x bar whole square. So that will be easy even the because the values are also easier. So this one you can find it at 286.3, and this is 364, and this one is 288.49. So you can see here is that the S value, the S value is bigger here, and then mean is smaller here. So anyway, this one will have a greater coefficient of variation, but specifically it will have 0.79 uh, to 5 something, and then it will have the variation of 0.55. So the answer will be the coefficient variation of B is greater than A, and then mean of A is greater than. Okay. So these two are the answers for this questions. Question. Sorry. Okay. So next question is that how do we solve the questions with interval form kind of thing. So if you have interval, class interval, and then how do we solve the questions for this? So here we want to find the mode. Okay. So the formula for mode, I think I can write it. So formula for a mode, if you have this kind of classes, you need to see firstly that if one class is ending at this point, then another class need to be start at that point. Otherwise you need to do something. I think if it is 30 to 34 and next one is from 35 to something, then you need to convert this interval. Like if you have first interval as 30 to 39, let's say, and second one is from 40 to uh, 49, then you need to convert these type of cluster intervals into 30 to 39.5, and then 39.5 to 49.5, in case you will go through the question this. So uh, the formula for the mode is xl plus f at 0, f at minus 1, and then f at 0 minus f at minus 1 plus f at 0 minus f at 1 into c. Okay, so I'll just write what are these things. So c is firstly the length. What is the length of interval? Okay, length of interval. So in the question you can see it whether it is 10 or I think it's 5. So 35.5 minus 30.5, it will be 5. And then F1 is the okay, let me tell you in the question itself. So C is the class length, so it will be 5, and then f0. So so model class interval. Then 60, 50. Just a minute. Should be two units. Maximum number. So this is the number of students. This is the maximum number of students. So this one will correspond to the class interval. Okay. Now this corresponding one, this will be f0. So this maximum value will be f0, and then f minus 1 will be, uh, we have f minus 1 and f1. So f minus 1 will be this. Okay. So firstly you see where what is the maximum, and then that one will be f0, this one will be f0, and above one will be f minus 1, and below will be f1. Okay, so f minus 1 will be 12, and then f1 will be 15. And anything left is that xl is was lower limit of the model class. So we have this as the model class, so lower limit is 45.5. Okay. And C we have already found. So these are the things which we need to find the mode. So now we can just put the formula here. The mode is what? The mode is XL plus C f0 minus f of minus 1 divided by f0 minus f of minus 1 plus f0 minus f1. So XL is 45.5, and then f0 is what, 19. F minus 1 is 12 divided by 19 minus 12, and plus 19 minus 15, and then times 5. And then you can calculate it. So the final answer will be 48.6. Understood? Here, okay. Okay. So I think it will be like at this point. Okay, class interval. So we have divided the values, number of students. This is, I don't know whether it is marks or something, but you can just think that if it is marks, okay, and this is the number of student with this marks, okay, or maybe like attendance percentage. So class interval can be anything. So it can be like said attendance percentage or marks or anything, on which on the basis of which you can grade it. So then you have the number of students. Okay, so what we are saying is that in between 30 to 35 you have 10 students, in between this to this you have 16 student. So if you have found this mode as 48.68, so at this particular marks there is a possibility that the maximum number of students are have this mark. That's it. Yeah, because then no, let's say that you have okay, so let's say that you have this is mark sheet, okay, and in bit I'm just dividing it here in the 5, and on an average I'm telling that maximum number of student, or what we say is that on an average, like we say that on an average the marks is 40, okay, or on an average the marks is in between 50 to 60. What does it mean is that on an average, so there is first thing is that average mark is 60, or average mark is in between 50 60, or what is a thing is that on an average if we have, let's say, 100 students, then 50 students have marks in between 50 to 60. Okay, so this is the number of students. So firstly, okay, to find the mode, firstly what we have considered is that we have considered this value, like 19 at that point. This is number of student already maximum, so in between 45.5 and 50.5 we have 19 students. Okay, this is the maximum value, this is the mode. And then in between this, if we want to just see that in between 50 to 60, what is that the marks which occurred the maximum number of time, so then we will say that it is 55 or 56. So that is something like this, I as per as I know. So if we are saying this is the point, then this is the probably that most student get this mark. Okay. Uh, 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 it it will, yeah, it will be less, but I don't know if there is any way, like you can check, or I will also check that. Okay. So now we will move to the eighth question. Eighth question given here is that you have the data here in age group and the frequency, and again, like we want to find the median here. Okay, so to find the median, that means if you have let's say 0 to 10 you have 30, and then 20 you have 50 or something like that. So 30 and then 50, so at which point it has obtained the half of the number, uh, half of the frequency, let's say. Okay, so that one will be the median. So to solve this kind of questions, and to find the median here, the formula for the median is median is uh, xl plus n upon 2 minus nl divided by f naught into c. Okay, so xl is the point lower limit of the median class interval. Like here in this question we have say that this is mode class interval. Okay, so its lower limit we have taken. So for the median, what we will take is that we will take the lower limit of the median class interval, and NL, this one belongs to the cumulative frequency occurred just before. Cumulative frequency occurred just before median class. And then C, you know, this the length, and F naught is the frequency of median class. So to solve this, we need to find the cumulative frequency also. So cumulative frequency is nothing but it just you need to do this summation, is 50, and then this one will be 80. So you need to just 30 plus 50 and then 80 plus 54. So 80 plus 54 will be 134, and then 201, and then 260, 308, 347, and then last one is that 377. Okay, so this one is that cumulative frequency. Okay, so now what we do is that firstly we will find n upon 2. So n upon 2 is that n, this is total 377 divided by 2, just to find the mid value. This is 188.5, and then we will say where this value is occurring. Okay, 188.85. So this value will occur in this region. Okay, when, because here up to here 134 and then here 201. So this will be the median class interval. Okay, now median class interval, to find the median, what we will have is that we'll have median XL, lower limit, plus n by 2, minus uh, this is NL, cumulative frequency occurred just before the median class. So cumulative frequency occurred just before the median class is that 134. So 134 divided by F naught. F naught is the frequency of that. So this is 67, and this will be multiplied by the age group is 10. So it will be 10. So overall, we will have this value, and then after solving, it will be 38.3. Okay. So at the age of 38.13, it's the median. So if you take let's say 100 number of people and then divide it according to the age, so uh, 38.13 is the age where 50% of the people lie. Okay, the people lie. And after that, so this means that we have more younger people. Okay, so now next is that we need to find the mode of the last question. So that is again like this question, I think seventh one. So you have class interval, you have number of students, all you need to find is the mode. So mode, you can find it like firstly, this is the 67, so mode will also be. So now again, this is the, for the mode we will find firstly the maximum one. So this one is 61. So mode is that XL, which will be 30, and then plus X0 will be here 67, and then X0 minus F minus 1 will be 54, and F1 will be 50. F minus 1 is 54 and F1 is 59. So above 1 we will have 67 minus 54 divided by 67 minus 54 plus 67 minus 59 multiplied by the class interval 10. So this is the mode, and the answer will be 26.19. So now we understood that the median, that means up to 38, 38.13 years, 50% of the data lies. So most of the population live, sorry, 50% of the population live before this, and the maximum occurrence. So the maximum people have the age of 36.19. So this is just statistical data and nothing else. But yeah, exactly. If you work like this on the data of say 2,000 people and 3,000 people, then these number will be more accurate and accurate. So then you will definitely know that what is the average number of people lying in this age group or something like that. Okay. So so a tenth question is that this is based on now the all the questions after this will be based on the theory part. So this is we have x, y, and z three independent chi-square random variable with 1, 4, and 9 degree, and then its summation. So first is that x follows chi square with degree 1, y follows chi-square with degree 4, and z follows chi-square with degree 9. So what one will this distribution follow? So for this we have the rule is that x plus y plus z will follow the chi-square distribution with the degree summation of it. So it will be 1 plus 4 plus 9. It will be 19. Okay, so for all this, you need to go through the theory part. So I will tell some of it. Now, let's say we have this question where x1 up to x10 follow be independent random variable and this, and y1, y2 up to y10 follow this. Then we need to find the distribution of this. So this one is basically you can see this is t distribution. So if x1 up to x10 we have normal distribution, this follows normal distribution, and x y1 up to y10 this also follows the normal distribution with the different parameters. And then we want to find the distribution of this. So we write it like this. Firstly, x1 minus u1 minus u2, and then this will be s1 square sigma 1 square s2 square sigma 2 square whole divided by under root 20 sigma 1 square plus sigma 2 square. Okay, so this follows the t distribution, and t distribution is with the degree 20 minus 1 minus 1. So basically for this one it will be t 10 minus 1. This one will be 10 minus 1 for x and y. So it will be t 80. So we will go through this question later. I think we need to firstly see what are these distributions. So chi square distribution. I will not go in too much of detail that you can see in lectures, because then it will be too much. But the simple things I can tell you. Okay. So chi-square distribution is what? A continuous random variable W is said to be this and this with n degree of. So chi-square distribution is nothing but when if we have anything like uh, follows n zero one, or let's say n mu sigma square. If x follows this, then its x square will follow the chi-square distribution. And if we have this summation over n, then this will follow the chi-square distribution with n degree of freedom. So its degree of freedom just changed. So its uh, PDF is basically given by this. So PDF is given by 1 upon 2 to the power n by 2 gamma n upon 2 uh, e to the power minus w upon 2 and w to the power n upon 2 minus 1, where w is greater than 0 and n is greater than 0. Okay, so this is the PDF thing. Yeah, and just okay. So in the last, hello, is there any problem? The Vijay Raj. If yes, can yeah, can you use yeah, you can use Excel also for calculation. Vijay, can you please mute yourself? It's just too much of noise. Yeah, if you have any question, just write down in this box and then I will see it. Okay. If you have any doubt, you can just write it down here. So, in the last class, I have gone through this how to do this transformation. So, have you gone through the notes or sorry, the lecture I have given? Because that one is very important. So, maybe I can just tell you a little bit idea about of that so that you can understand this chi-square distribution also. How does it work? Okay. So this is, let's say, x, you have n 0 1, and then you have fx x at as given as 1 upon root 2 pi, and then e to the power minus x square upon 2. Okay, so x is in between minus infinity to infinity. It is not. Now, next is that we need to find y is equal to x square. Let's say this is what we call it as transformation. So we are doing a transformation of random variable. Now, how do we deal with this? Is that we will have x is equal to minus root y or x is equal to plus root y, right? So dx dy, for the transformation what we use is that uh, dy is equal to uh, sorry fy f of y is equal to dx dy, it's mod times fx. So I think you know it, maybe, or not. So this is dx dy mod. So in any case, dx dy will mod of it will be what, 1 upon, it will be uh, 1 upon 2 root y. Okay. So f of y will be what? It will be dx is dy plus 1 upon 2 root y. So let's just say 1 upon 2 root y, and then we can write x squared as y, so e to the power minus y by 2, and then multiply it with 1 upon 2 root y. Where does this 2 came from? So this one is 2 to the power half, this one is gamma half. Did I miss something? This is minus 1 by 2 x squared minus 1 by 2, and then it will be 2. Oh no, there is something missing, I think. But otherwise, this is 2 to the power half. This is root pi. Root pi, we can write it as gamma half. So this is, we can write it as gamma half. This is, we can write it as minus y upon 2. And this, we can write it as y to the power 1 upon 2 minus 1. And this is for y greater than 0. And this 2, there is some multiplication of 2 written here, but I don't know. I think I have missed something. So that I will check and I'll let you know this, if there is any issue. Means in the time of uploading, just go through this. So this is the chi-square distribution, and next is t distribution. So if you have t distribution, so t distribution is what? If you have again x and if you have x and y, two independent random variable, which follows n 0 comma 1, then t is equal to, we say, under root n y, t is equal to x upon root y by n. Okay, so for this we use the t distribution, and it will follow n degree of freedom. So so the PDF of t distribution can be given by f t of t is equal to gamma n plus 1 upon 2 divided by gamma n upon 2 gamma half root n, and then 1 plus t square upon n to the power minus n plus 1 upon 2. Okay, so this is the PDF of t distribution, and next is that next we have f distribution. So f distribution is what? If you have, say, two independently distributed function with chi-square distribution. So till now what we are taking is that one is, both are following the normal distribution, and then what's the one function defined in the terms of x and y, and what does its distribution. So it will be chi square or t, or sometimes it will be unknown also that we can solve. So if we will have time, then we will go through this one transformation, that how do we solve the transformed value and all. So app distribution is what? Let's say you have y1 and y2, v2 independently distributed function, sorry, random variables, and then uh, y1 follows chi-square with degree m, and y2 follows chi-square with degree n. Then if you have function u is equal to y1 by m divided by y2 by n, then it means it is n by 1 divided by m by 2. Then this will follow f distribution with degree m comma n. So degree of this is m, degree of this is n, so it will follow m comma n. And yeah, so I think here we can use this, which I was telling, the transformation or something. So let's just say, firstly, since y1 and y2 are what, independently distributed. So whenever something is independently distributed, so it's f y1 y2 will be equal to what, f of y1 times f of y2, because it is independently distributed. So both are chi-square distribution. So for chi-square distribution, the PDF is what, 1 upon 2 upon, sorry, 1 by 2 to the power n by 2. So it will be, for the first one it is n, second one will be n m, so it will be n plus n by 2. And then similarly, the other things will go. So it will be n, sorry, sorry. So it will be 1 upon 2 to the power n plus m upon 2. And for the first one, it will be gamma m by 2. For the second one, it will be gamma n by 2. I think. Yeah. Okay. And then it will be e to the power minus y1 plus y2 by 2, y1 to the power n, y1 to the power n, I think, and y2 to the power n by 2 minus 1. Okay. And here y1 comma y2 are greater than 0. Okay. Because this is what x is square. So x is in minus infinity to infinity. So y1 will be greater than 0, and similarly for the y2 also. So this is the distribution for f of y1 comma y2. Now we want to find f of u, and then here we will use this called transformation. So transformation is basically what, till now what we did here, like this, and here, yeah, yes. So what we did is that we have one random variable, and then we have converted it into some other form, like some other random variable is given in the form of the first random variable. So what we have is that we have one conversion. So we have just multiplied d mod dx by dy. But in the term of two variable and then converting it to another two variables, what we do is that we take the Jacobian. So do you know what is Jacobian? Okay, so yeah, it's basically the determinant. So it is the determinant of d. Let's say you are converting u and v in the form of u and v, so it will be del u del of function of u divided function of uv divided by u, and then something like that. So we will do it next. So we are considering here the transformation as v is equal to y2, and then u is equal to n by 1 divided by n by 2. Now here is that it's not needed that you need to take this transformation only. You can take the other one also, but we will try to take the simplest one. So when you will solve the question on your own, it may happen that you may take this transformation and then you may take this transformation. The answer will be same, but then your method will define whether it will be smooth or it may go on difficult. So you can just sometimes try. So these questions will come when you try only. Okay, so now we will find y1 and y2 in terms of this. So y2 is equal to b, and then y1 is equal to what? M divided by n u v. Okay, so we have y1 and y2. Now the Jacobian is that. Now rather than d, we will have del, because that will be the partial differentiation. Okay, so del of y1 divided by del m, sorry, del u, del of y2 divided by del v, and then del of y1 divided by del of y2 divided by del u, and del of y2 divided by del v. So here in u it will be m upon n v. Here with v it will be m upon n u, and here with u it will be 0, and here it will be 1. So it will be ultimately m upon n v. So that one will be the Jacobian. Okay, so f of u v is what? F of this y1 and y2, but in terms of u v we write, and then this mod of Jacobi. So now you will have e to the power, now y1 plus y2 upon 2. So y1 plus y2 upon 2 will be what? M u v plus n v divided by. So firstly, um, so these terms will be the same where there is no y1 and y2. So this will be the same, 2 to the power m plus n upon 2 gamma m upon 2 gamma n upon 2. That will be same. And then we will have one multiplication of m upon n v, which is Jacobian, and then e to the power. Now y1 plus y2 upon 2, we can write it as 1 plus y2 upon 2. So v is common here, so we can take v upon 2, and then it will be 1 plus uh, m upon n u, right? So it will be e to the, oh my god, e to the power minus v upon 2, 1 plus m upon n u, and then it will be multiplied by uh, y1 to the power m by 2 minus 1. So y1 is what? m upon n uv. Is there any issue? Is there any issue? Kripa? Kripa, is there any issue? If not, you can just mute yourself. Or if you have any issue and I'm unable to hear you, you can write it in the chat box and then I'll say it. Okay. So next one is that y1 to the power. So y1 is what? M upon n uv to the power m minus 1, I think. No, m by 2 minus 1. And then y2 is v to the power n upon 2 minus 1. So this is the thing we have. Now we can just subtract it. You for the v to simplify this and this will remain same, and for v the power here is that m by 2 minus 1. So minus 1 minus will be cancelled out with this one. So ultimately we will remain with m by 2 plus n by 2 minus 1, and then for u m by 2 1 m by 2 will be cancel out. So for the u it will be n by 2 minus 1, and the remaining one will be here it is minus 1. So 1 mn will cancel out. So overall it will be mn to the power m by 2. So this is not division, this is all multiplication here. Okay. So 1 mn minus 1 will be cancelled out, and the other one is that mn to the power 2. So the final PDF we will have is that 1 upon 2 to the power n plus n upon 2 gamma m upon 2 gamma n upon 2 e to the power minus v upon 2 1 plus m upon n u v to the power m plus n upon 2 minus 1 u to the power m upon 2 minus 1 and m upon n to the power m upon where u and v both are greater than 0, because you can see this is greater than 0 because y2, and this is u is y1 and y2 both are greater than 0, so u will also be greater than 0. So this is the final PDF, which is FUV, and this is what is F distributions PDF, marginal PDF, and then you can write this and all by just writing it in the beta form and all. So this is for the this is for joint distribution. Now we have u is equal to what we have given here. U is equal to this is the F distribution. So F distribution is nothing but if we can find the marginal PDF from here. So this is the joint distribution. So for marginal PDF of u, marginal PDF of u, that will be F distributions PDF. So marginal PDF you can find from here. You can find from here. So marginal PDF will be m upon n to the power m by 2. This is same, and then this is beta m upon 2 n upon 2 u to the power m upon 2 minus 1 divided by 1 plus m upon n u m plus n upon 2 and u greater than 0. So that one will be the PDF of, sorry, this one is PDF of F distribution. Okay, and u follows f of m comma n. Now the other thing is that 1 upon u will be what? The opposite of, just if we reverse the role of by 1 and by 2, then it will be 1 upon u. So if u follows f of m comma n, then 1 upon u will follow n f of n comma n. So this is very important result, may use at different places. So this is basically all about distributions. Now we can go to the questions. So the 10th now question is here is that what is this? X1 up to x5 and y1 up to y5. These are independent normal, independent random sample, and these are from the normal distribution 1 comma 9, 1 comma 9, and n 0 comma 9. Okay, so xi follows n 1 comma 9. Okay, yi follows n 1 comma 9, and then zi follows n 0 comma 9. Okay, so now x I minus yi. Okay, so firstly we will see what this follows. So xi minus yi will follow normal distribution 1 minus 1, and these are all independent. Okay, so xi minus yi, let's say x1 minus y1. So this will follow 1 minus 1, mean subtracts and variance adds. So variance of x plus x minus y or x plus y, it doesn't matter, it is always the variance of x plus variance of y, right? So this is 0 comma 18, and zi follows n 0 comma 1. So the summation is square. This is what? This is square, so n is square. So if we have any zi which is x, sorry, not say zi, let's say ui which is xi square, then it will follow what? Chi-square distribution. I have just told you earlier that this will follow the chi-square distribution. So chi-square distribution, the above one follows chi-square distribution and with the degree 5, right? And the next one follow chi-square distribution. Zi is, this is also random variable and it's square. Okay, this follows chi-square distribution with 10. So what we know is that if one follows chi-square distribution with this and another follow chi-square distribution with this, then its division will follow the chi-square distribution. Yeah, first, and then also you need to do is that it's I think you need to just write is square, and then it will be, if it will be division and multiplication by 5. So that 1 upon 5, this will follow, sorry, so 1 5, yeah, no, I don't think so. So this will follow 5 and this will follow 10, so it will follow f 5 comma 10. So it will be f5 comma 10, and tn will not come here. This is not distribution. This is also not chi-square distribution. So in between these two, you need to check which one this is. So next question we need to solve. I will solve it the later, and then this. Firstly, we will do this question, then we will go through that solving question. we will discuss. Okay, so question is that which among of the following distribution is true? So student T distribution is asymptotic and 0 1 as the, so T distribution, where is T distribution given? Okay, here. Okay, so I have already written that xi and y are independent and 0 1. So it will be n 0 1. Now we need to check whether it is where it will go if we say that n tends to infinity. So this is the distribution given here, and f ft by t. So as n tends to infinity, as n tends to infinity, this is root pi, and this is root n tends to infinity. This gamma n plus 1 upon 2 is n plus 1 upon 2 gamma n, and then it will be this value as n tends to infinity goes to e to the power minus t square upon 2. Then you need to go through some limits and all. Otherwise, if you have 1 plus x upon n uh, to the power minus something, and then it will go to e to the power minus x. So this is how it works. So this is e to the power minus t square divided by n multiplied by n upon 2 plus 1. So it will be e to the power minus t square upon 2. This will go to minus t square upon 2, and this will be 1 upon root 2 pi. So student t square distribution is asymptotic and 0 1. This is what this is when this is basically what n 0 1, right? And 0 1 is what 1 upon under root 2 pi to the power minus x square upon 2 if you have x as this. So this will be the correct answer. And then what you have here is that you have independent functions xi as independent function and mu comma 1, and we have here 2n number of terms, but here you can see you have n number of terms. Okay, so 1 upon 2 sigma I is equal to 1 to up to n x 2I minus 1 minus x 2I square. Okay, so this is n number of terms. You can take this as some ui. So we have this 1 upon this I is equal to 1 to up to n. Okay, this is ui square. So this summation ui square 1 by 2 is just a constant. So summation ui square, where ui is following, because see x2i minus 1 and x2i both follows normal distribution mu comma 1. So x2i minus x2i will also follow the normal distribution x2i minus 1 minus x2i will follow normal distribution with 0 comma 2. Okay, so this is also a normal random variate. So normal random variate square will follow this square will follow chi square, and its summation is up to n. So it will follow the chi square distribution with n degree of freedom. So that one will be the answer. Now next question we have this, and this, we are left with these two questions. So these are again the simple mean and uh, the normal formula of mean and all is required here. Okay. So what's given here is that summation xi is equal to 120, I is equal to 1 to up to 8, right? And summation xi square is 1880. So this is given. Okay. So now we know the variance of x is what? 1 upon n summation xi minus x bar whole square. Okay. I is equal to 1 to up to 10, right? So and the variance is equal to is also equal to uh, e of x square minus e of x and its whole square, right? So this is its value is given, so we can see that variance is what? 1 upon 10, this is 490, so this will be 49 is equal to expectation of x square minus expectation of x whole square. So now you have given summation xi is equal to 120 and xn is equal to summation xi is equal to 120 up to 8, x9 is equal to k, I think, and x10 is equal to minus k. x10 is equal to minus k. Shit. So summation xi up to 10 will be what? 120 plus k minus k, it will be 120. So average of it will be 12. So this one is expectation of x, and then expectation of x square will be what? The summation of xi square is up to 8 is 1880. So it will be 1880 plus, for this case, this is k square, this one will be k square all divided by 10. So it will be 1880 plus 2k square divided by 10. So now we know expectation of x square and expectation of x, and then we can put all these things in this equation. So it will be 1880 plus 2k square divided by 10 minus uh, expectation of s square and divide is equal to 49, right? So it will be 1880 plus 2k square minus 1440 is equal to 490, right? So 2k square will be all this minus, and I think it is this is 490 minus 0, 4, and 18 minus 14, 4, it is 50. So k will be 5, right? K square will be 25, so k will be 5 because plus minus 5, here absolute value we need to find, so k is equal to 5 will be the answer. Uh, Now, last question here is that if the mean and the variance we have given of 10 observations were found to be 60 and 110. Okay. So mean is what? uh, mean, सबसे firstly we have n is equal to 10, mu is equal to 60, and then sigma square is equal to 110, right? These things are given. So later it is observed that an observation 80 was wrongly read as 70. So 80 was wrongly read as 70. So we need to find the correct mean and variance. So it may happen is that one value is we have read was wrong. So then what is the corrected mean and variance? So mean is, let's just say this is the last value. So up to xi 9, you have the values which were right. So plus uh, 70, when it was 70, the mean was what? 60. So now we want to find what will happen when it will be 80. So it's just that xi 9. Okay, so we are adding 80, and we are saying that we are removing this 70. So now this is the change we have done. So summation xi by 10. So it will be what? 60 plus 80 minus 70 divided by 10. So this is the change we have done here. So this will be 60, and then 80 minus 70 will be 10. So 10 by 10 it will be 1. So this will be 61. So this is new mean. So that is the answer. But anyway, we will solve this for the variance also, so that you will understand how to solve for the variance. Now, for the variance before was 110. So 110, let's just say, is equal to, then it was x square, say, when we have before the corrected version. Okay, and this is expectation of x whole square. So this is 110. This is expectation of x square, and that time expectation of s, that means that time mean was 60. So it was 60 square, right? So expectation of x square will be what? 3600 plus 110. So it will be 3710. So now if we can find the corrected expectation of x square, we already have corrected expectation of x, then we can find the corrected variance. So expectation of x square, similar thing we will do here also. Xi is square uh, up to 9 plus this 80 is square minus 70 is square divided by 10, and then it will be equal to 3710 plus 80 is square minus 70 is square divided by 10. So this one is 3710, and this one will be 6400 minus 4900. It will be 1500, so it will be 150, right? So it will be 3860. So 3860 will be expectation of x square. So now variance of x will be what? 3860 minus 61 square. So it will be 3860 minus 61 square is 3721, and then 3860 minus 3721 will be 139. So It was already given. Okay, this 139. Okay. Sorry. So these are all the questions we have for today. If you have any doubt, you can ask me. And um, I think we have some time left. Yeah. Actually, I have questions here. So, uh, have you gone through the lectures like Sir has taken? Okay, so maybe there you may have questions because in the real life is that uh, generally in the time of fitting distributions we use all these things, whether it is fitting chi-square distribution of f distribution and all, and then we work on like if it follows this distribution then we can predict the future data. So this is how I work. But in the real life, like particularly how particularly where we can use this distribution, I have not gone through all these things. So maybe you can check that in like net, you can search that. But otherwise, like all these distributions we generally take like normal distribution generally we take for everything, and exponential sometimes, and for the discrete we use Poisson or binomial. I think these are the common distributions we use. And other than that, in daily life, you say, so in daily life we don't use generally all other distributions as far as I know. But in the time of, if you are working on the statistics specifically, if you are working on the data specifically, then you generally go through all this distribution which are like gamma, beta and all. Yeah. Okay. Anything else? Bell curve. So these are bell shaped. Like I think this is also even bell shaped. Na normal distribution is bell shaped. Yeah. So that is means how much, like in mu minus sigma mu to sigma, how much is the data, and then minus twos, and then all. Yes. So, most probably in the next class, we will go through this estimator, which is unbiased estimator, and then I think I don't remember the other names of estimators. Just- Okay, so right now I don't remember. I will go through all these things. I think that we, yeah, this is point estimator, interval estimator, and then we will give, yeah, consistency. So consistent operator, and then we will estimator, sorry, and then we will go through how do we find these estimators, and then what is the use of this distribution. So we will all meet on the next class Tuesday, next Tuesday. So thank you all for joining. Okay, so I'm just closing the meet for everyone. Thank you for joining.